In Abaqus CAE, you can create geometric faces from element faces. This is a manual process in which selected orphan element faces are combined into a single geometric face. Whenever possible, Abaqus CAE will create analytical geometry, such as a plane or cylinder, on the selected element faces. In this demonstration, I will be creating geometry from a mesh of the grip part in this crimp forming example. The grip is colored red in the lower two animations. I will begin by importing the orphan mesh from an input file. I will switch to the Part module and open the Geometry Edit dialog box. I will select Face as the category and From Element Faces as the face creation method. For a regularly shaped part such as this one, the analytic selection method is best, since it allows me to easily select regions of the mesh for which Abaqus can and will create analytical geometry. Note that if I hold the Shift key to select more than one analytic region at once, a single face is created. Note, however, that the resulting face is not analytic and the edges between the three selected planes have now been smoothed over. Two factors which may reduce the quality of the new mesh I plan to create on this geometry. To remove the face, I will expand the features list for the part in the model tree and delete the Face From Mesh feature and recreate the geometry using individual analytic regions. Next, I will show you a few of the other element face selection methods. First, I will switch to the By Limiting Angle method. With this option, I can select the element faces whose normal lies within the specified angle of the selected element face, allowing me to select a narrow strip of the curved bottom of the grip. If I want a wider selection region, I can simply increase the angle. Keep in mind that this angle is always measured relative to the selected face, which is different from the By Angle method, which is based on the angle between the normals of neighboring element faces, allowing me to either select a narrow strip or a face that extends all the way up the sides of the grip. With the Layer Selection method, I can specify how many layers of element faces around the picked face I would like to select. These alternative selection methods can be useful if you need to isolate particular regions for loading, output, or other analysis features. The ability to easily control and limit your element face selection area can also greatly improve the geometry creation results on meshes that represent highly irregular geometry, such as this jawbone implant. For this grip part, however, I will return to creating as many faces as I can using the analytic selection method. Note that as I add new faces, Abaqus CAE will attempt to stitch the new faces to any existing neighboring geometry to produce a shell part. What Abaqus does not do automatically, however, is associate the underlying orphan mesh with the new geometry. This means that if I apply a load or any other analysis feature to the new geometry, it will not be transferred to the underlying orphan mesh. Therefore, if I do want to use the underlying orphan mesh, I need to switch to the Mesh module and associate each geometric face with the underlying element faces. A more typical use case for the mesh to geometry functionality, however, is to delete the underlying orphan mesh altogether and create a new solid part mesh. Returning to the Geometry Edit dialog box, I will select Edge as the category and Stitch as the method to eliminate any gaps that may not have been stitched automatically. I will allow Abaqus to update the validity of the newly stitched part. You can see that while stitching the part, Abaqus has also converted the shell geometry into a solid, which I will use to create a fine mesh of tetrahedral elements.